BVS Pragati channel welcomes you. In this session, we'll have a discussion about antennas. As part of that, we'll first discuss about the terminology of antennas, such as radiation resistance, efficiency, directive gain, directivity, power gain, beam width, bandwidth. And later, we'll go ahead and discuss about elementary doublet, and we'll follow it up with resonant antennas and non-resonant antennas. So, we see that antennas normally follow reciprocity theorem. That is, if a transmitting antenna is transmitting, it can also receive. This is called radiating system. So, what is radiation resistance? Ratio of power given to the system to the square of current at the feed point. So, RR is equal to PT by I square or 790 L by lambda whole square. Efficiency. Efficiency is equal to power radiated by the antenna by power given to the antenna. So I square RR by I square RR plus RL. So what is RR? Radiation resistance, and RL is load resistance. So the more the radiation resistance, the more will be the efficiency. Directive gain. Ratio of field strength obtained by an antenna under test to field strength by reference antenna when fed with same power. Directivity. Maximum directive gain is called directivity. And power gain. Ratio of power fed to the reference antenna to the power fed to the antenna. AP is equal to PR by PT. Beam width. Angular separation between two half power points on power density radiation pattern is called beam width. So bandwidth, the frequencies which an antenna can respond to is called bandwidth. Now let's have a look at the elementary doublet. So the elementary doublet is a small length of wire which is far less than its wavelength. Okay, so let's say there's a frequency which it has to transmit. If you determine the lambda, L is far less than lambda. It is a very tiny antenna. Current at every point in elementary doublet is same. So this is a small elementary doublet of length L. Okay, so here is the radiation pattern of a elementary doublet. We see that the radiation is maximum at right angles to the dipole and it falls to 0 in line with the antenna. So at right angles to such a short piece of wire, the distance from remote point, okay, to any point in wire is the same as its distance to any other point. So what happens? At 90 degrees, reinforcement of radiation happens. Hence, the radiation pattern is maximum. So when the distance point lies in the plane other than the normal, so when it is lies in line with the plane, what happens? Maximum cancellation occurs, and when it is in line with the antenna, the radiation pattern is 0. So as theta falls to 0, this one, the radiation pattern due to this and the radiation pattern due to this cancels out each other, and what happens? When it is in line with the antenna, radiation pattern becomes 0. So the radiation pattern of an elementary doublet is that of a figure of 8. Okay, now let's go ahead and discuss about resonant antennas. So what are resonant antennas? They are open circuited transmission lines. They are opened out transmission lines, and these transmission lines are open circuited at far end of resonant length. So these are normally multiples of quarter wavelength, and the total length is multiples of half wavelength. Lambda by 4 plus lambda by 4 becomes lambda by 2. And you see that the low impedance source is placed at a low impedance point, and this low impedance point happens to be at quarter wavelength from the open circuit. Okay. Now, we see that for a lambda by 2, so lambda by 4 plus lambda by 4, it makes it as lambda by 2 line. So for a lambda by 2 dipole, the directivity is 1.64 and RR is 72 ohms. The radiation pattern of a lambda by 2 line is similar to that of a elementary doublet. So the similar process happens. Because of the radiation from this point and the radiation from this point at angle at 90 degrees, what happens? Reinforcement happens, and then the radiation is maximum. And when it is in line with the antenna, the radiation due to this and the radiation due to this cancel out each other and it becomes 0. Okay. Now let's consider a lambda line. So we see that in a lambda line, this length is lambda by 2, this is lambda by 2, thus making it totally lambda dipole. Okay. Now, due to the radiation, so at right angles, the radiation from this and the radiation from this is opposite in nature and they cancel out at 90 degrees. Hence, at 90 degrees, the radiation is 0. But maximum radiation still occurs, and that occurs at an angle 54 degrees. Okay, now let's have a look at 3 lambda by 2 lines. So 3 lambda by 2 lines by 2 is 3 lambda. So it should be 3 lambda by 4 lines here, 3 lambda by 4 lines here, which makes it as 3 lambda by 2 lines. So in 3 lambda by 2 line, what happens? There is radiation at 90 degrees to the antenna, but the extreme end, the radiation from the extreme end add together, but the radiation from the center is opposite in polarity to the radiation from the extreme ends, and this cancels some of the radiation. Hence we see that there is radiation at 90 degrees to the antenna, but it is not maximum. This becomes a minor lobe now. And the maximum radiation occurs at some other angle. So these are major lobes and this is a minor lobe. So there are 3 lobes on each side. And for a 3 lambda by 2 antenna, and by 3 lambda line, you have 6 lobes on each side. Okay, now let's have a look at non-resonant antennas. So what are non-resonant antennas? The radiation pattern of a non-resonant antenna is unidirectional. Now we will see what grounded antennas are. Grounded antennas are also called vertical antennas. And they are also called Marconi antennas. They are lambda by 4 antennas. And these antennas are normally used in ground wave propagation. They require less length because for example, if there is a lambda by 2 line, okay, and image of lambda by 2 line away from it is seen, okay, in case of ungrounded antennas. Okay, what is top loading? Top loading is to increase effective length of antenna. Artificial mats create perfect reflection from ground. So ungrounded antennas are called horizontal antennas and they are also called Hertz antennas. So in case of ungrounded antennas, what we see is, for example, if you have a lambda by 2 line, it appears like a lambda by, it appears that the radiation pattern is due to 2 lambda by 2 lines. How? Image of it is formed beneath it at a distance equal to the length of the antenna, and because of this you have direct radiation from the actual antenna and there is reinforcement of radiation from the image antenna. So hence the total and the net effect is reinforcement. So in the next session what we'll do is we'll discuss about ungrounded antennas, and then we'll also discuss about grounded antennas, which are also called vertically grounded antennas. Then we'll go ahead and discuss about broadside array, and then also about end fire arrays. So in the nutshell, what we have seen in this session, we have discussed about the terminology related to antennas. Then we discussed about elementary doublet. And we have also discussed about resonant lines, non-resonant lines. We have seen topics like top loading and artificial mats. So in the next session, we'll discuss some more topics. Thank you. Thanks a lot and I wish you all the best.